Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about alcohols, phenols, ethers and epoxide. That is CC6 paper in Unit 2 and Lecture 1. So this will be highly useful for BSc Chemistry students under CBCS syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about alcohols, mainly preparation, properties and the relative reactivity of primary, secondary and tertiary alcohols. So first of all, we should know what are alcohols, phenols, ethers and epoxides. So generally we know the general formula of alkanes is R hyphen H. So now if we substitute hydrogen with a hydroxyl group, that becomes ROH. So this is the general formula for alcohol. So when this R group will be C6H5, so this becomes C6H5OH, that becomes phenol. Similarly, in alcohol ROH, if we replace hydrogen with a R group, then that becomes ROR. Those are called ethers. Similarly, these cyclic ethers are called epoxides. So this is a three-membered ring. So here are some examples of alcohol. So this is the simplest alcohol, CH3OH, that is known as methanol. C2H5OH, ethanol. C3H7OH, propanol. Similarly, we have a dihydroxy compounds. So CH2OH, CH2OH. So that is called ethylene glycol. Similarly, trihydroxy alcohol, CH2OH, then CHOH, CH2OH. That is called glycerol. So now let's talk about the classification of alcohols. So generally the alcohols are classified as primary, secondary and tertiary alcohols. So in primary alcohol, the hydroxyl group is attached to a carbon which contains two hydrogens. Similarly, in secondary alcohol, the hydroxyl group is attached to the carbon which contains only one hydrogen. Similarly, in tertiary alcohol, the hydroxyl group is attached to the carbon which does not contain any hydrogen. So in vicinal diol, so this is dihydroxy compound. When the hydroxyl group at 1,2 position, that is called vicinal diol. When the same hydroxyl group at the same carbon 1,1 position, that is called gem diol. So let's talk about preparation of alcohols. So alcohols can be prepared from alkyl halides. So Rx, the general formula of alkyl halide, it can react with potassium hydroxide, and if we boil it, we can get ROH plus potassium halide. So the limitation of this reaction is, the limitation is a major problem with secondary and tertiary alkyl halide. So if we take tertiary and secondary alkyl halides, it will undergo elimination reaction. So we can prepare again alcohols from toluene. So if we heat chlorine with toluene, so we get benzyl chloride. Then you can react with aqueous sodium hydroxide. So benzyl chloride can be converted to benzyl alcohol. The next is hydration of alkenes. So this is indirect method of hydration. So alkene can react with sulfuric acid, giving rise to this intermediate. So which further upon reacting with water or on treatment with water gives rise to alcohol. Similarly, alkene can react with sulfuric acid. So it will end up with this intermediate, so which upon further treatment with water giving rise to the alcohol. And the direct hydration means alkene can react directly with water in presence of acid catalyst. So it will give you protonated form of this intermediate. So upon loss of this proton giving rise to alcohol. The next method is reaction of Grignard reagent with carbonyl compound. So we know the structure of Grignard reagent is R minus Mgx plus. So here R minus will act as nucleophile, so it will attack carbonyl carbon, and CO double bond will break on oxygen. So as a result, we get this RRRCO minus MgX plus. So which upon treatment with H plus and water giving rise to alcohol. So if you start with ketone, you will get tertiary alcohol. If you start with aldehyde, you will get secondary alcohol. And if you react Grignard reagent with formaldehyde giving rise to primary alcohol. Similarly, Grignard reagent can react with epoxides. So R minus will attack to this CH2 and this CO bond will break on oxygen. So upon hydrolysis, you will end up with alcohol. The next method is reduction of a carbonyl compound. So in catalytic method, so let's start with acetone. If you treat with hydrogen and platinum oxide, you will end up with alcohol. Similarly, you can go for sodium ethanol, so that will also give rise to alcohol. Similarly, metal hydride reduction of carbonyl compound giving rise to also alcohol. So let's say carboxylic acid. It can react with lithium aluminum hydride in ether giving rise to alcohol. So this is the mechanism. So lithium, this is the structure of lithium aluminum hydride, Li plus AlH4 minus. So here hydride takes this proton of carboxylic acid. So as a result, you generate RCOO minus Li plus hydrogen plus AlH3. So this AlH3, now the hydride attack to this carbonyl carbon and CO double bond will break on oxygen. So as a result, you end up with this intermediate. So this when this O minus will come back, so CO bond will break on oxygen. So as a result, you end up with aldehyde. So again, once you get aldehyde, so a lithium aluminum hydride again transfer one of the hydride to the aldehyde. So as a result, you end up with this lithiated compound. And upon treatment with water, you end up with primary alcohol. Next method is hydroboration oxidation reaction. So it follows anti-Markovnikov's addition. So you start with alkene and you add boron or diboron B2H6. So you get boron derivative. So which upon treatment with hydrogen peroxide and OH minus ion. So it gives alcohol. Similarly, we can prepare alcohol by oxymercuration and demercuration reaction. So we take alkene and we react with HgOS2 and sodium borohydride. So you end up with alcohol and it follows Markovnikov's addition. So if we start with acetylene and we give the same reagent HgOS whole twice and sodium borohydride, we end up with ketone. So this is the mechanism of hydroboration oxidation. So if we take alkene and we react with BH3, so here this BH3 will be added in this fashion. So this double bond will attack to this boron and H will attack to this carbon. So here you can have a transition state like this. So you end up with this intermediate. So again another molecule of alkene will add another two molecules of alkene will be added. So you get tri alkyl boron derivative. So once you end up with this, then oxidation takes place with hydrogen peroxide and OH minus ion. So it gives water plus peroxide anion. So this peroxide anion will attack to this boron. So then what happens? You end up with this intermediate. So here R minus will move to oxygen and it will kick out OH as OH minus. So you end up with RBROR. Then again you react to another equivalent of peroxide anion. So you get dialkyl borate. Then you treat another equivalent of peroxide anion till you get this trialkyl borate. So which upon treatment with water giving rise to alcohol and H3BO3. Similarly, here is the mechanism of oxymercuration and demercuration reaction. So we take alkene and we react with HgOAc, water and ether. So we get this intermediate, which upon treatment with sodium borohydride we get this alcohol. So here is the alkene, simple alkene RCH double bond CH2, and it will be added to HgOAc whole twice. So CH double bond will attack to this mercury, and lone pair will attack to this carbon, and one of OAc will be eliminated as OAc minus. So you will have intermediate this. So then water will attack to this carbon, and this CHG bond will break on Hg plus. So you end up with this intermediate. So here the OAc minus will take the proton from here, OH2 plus. So you end up with this alcohol. And when you treat with sodium borohydride, so this carbon mercury bond will break. So you will end up with RCHOH CH3. Similarly, if you take alkyne and you treat HgOAc whole twice and sodium borohydride, you end up with this enol, which again tautomerizes to ketone. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. So this is the another channel for class 11th and 12th students, Foundation Chemistry AV. So this is a simple step towards e-learning, making life better. Thank you for learning.